So here's a limit question, and we're taking the limit of this function as x approaches 1. So the first thing you do, as always with limits, is think about direct substitution. If you do direct substitution, the bottom would be 1 squared minus 1. So now I can see here if the bottom's anything other than 0, the answer will be 0, because 0 divided by anything is 0, except 0. So if you plug in 1 to the side of pi x, you'll get the sine of pi. And the sine of pi is 0, because the y-coordinate would be 0 at pi. So you have this 0 over 0, which indicates an indeterminate limit. So it just tells you the limit can't be determined with just this direct substitution. But it is a form that you can use L'Hopital's rule on. Anytime you get 0 over 0 or plus or minus infinity over infinity, you can use L'Hopital's rule. So that's what we're going to try. And to do that, you just take the derivative of the top and the bottom, and the limit's going to be the same. So this original limit would be the same as this new limit, which is the derivative of the top, 2x, over the derivative of the bottom, which is the cosine. It's a chain rule. Leave the pi times x alone. So that's the derivative of the outside. Then times the derivative of the inside, which is the derivative of pi x, which is just pi. So now we're going to calculate this limit. If we get a limit, it will be the same as the original limit, according to L'Hopital. So if you plug in 1 with direct substitution, you're going to get 2 up top. So this limit is going to be able to be determined. If you plug in 1 on the bottom, you'll get pi times the cosine of pi. The cosine of pi is negative 1. So this would be 2 over negative pi, or just a negative pi over 2. Now you should check that with your calculators just by taking the original function and maybe plugging in 1.0001 in for the x's and make sure it's close to that value.